I want to talk about angle-pair relationships, but before we do that, I want to really focus on the first word there, angle. So let's look at a few circles here. So I've got three circles all around the same center point. So I have this circle, and farther out I have this circle, and farther out I have this circle that's so big that I can't even fit it all on the screen right now. So it's and it wouldn't even print out on the paper because I ran out of space. So we can have all different kinds of circles, all different sizes, right? But the reason that I'm showing you this is that, and we'll learn later in the year, these are called concentric circles because they have the same center, concentric. But the reason I'm showing you this is that I have an angle right here, okay? And this angle right here, so this angle going with that line and that line, that angle is 33, almost 34 degrees, 33.9 degrees. But if you notice, it does not matter if I'm talking about this circle, if I'm going from there to there, or if I'm going from there to there, or if I'm going all the way out to the big circle, they're all the same size. They are all 33.94 degrees. So it does not matter if you're doing a smaller circle or a larger circle or an even bigger circle. Angles are the same. Okay, so the size does not matter. And I could also have come in here and instead of having just a regular circle, I could have done something crazy and just made this like some, crazy shape, or let's just say I just take this out. I'm just going to white out over this. Okay. Let's just say it wasn't really a circle, but it was some crazy shape, and then it still came back in like this. Notice that the angle is still the same, right? The angle is still the same measure. And in this case, it would be the same. If you notice what I'm doing here is I'm just saying this is the same, even though it is not a circle and it's some crazy shape. Oh my gosh! And then I'm just looking at this piece right here, right? It's still 33.94 degrees in the angle, right? That is still 33.94 degrees. And so, and this has a special name. The fact that this angle is the same as that angle, we're going to learn that today. That's called a vertical pair. But I just wanted to make sure that we start out on the right foot by understanding that angles have nothing to do with the shape or the size of the thing that you're measuring. It's simply the amount of rotation from one side of the angle to the other side of the angle. That's what defines the size of the angle. And in an entire circle, if we go all the way around, it's 360 degrees, right? And so then halfway around, just a semicircle right here, would be half of that, which would be 180 degrees. Okay? And then if you split that in half and you just did a quarter of it here and looked at that, well, everybody knows that is 90 degrees. So 90, 180, down here would be 270, and then finally 360 all the way back around. Okay? Alright, just a little review on angles. So we're going to talk about angle-pair relationships, and this is the kind of a thing that you're really going to have to be very comfortable with in geometry, because we're going to rely on this type of information all the time, and you need to really understand it so that you don't have to keep going back and looking at stuff over and over again. So some new vocabulary. We've already learned the word complementary and supplementary. This just means two angles that add up, or I guess two or more. Usually it's just two angles. But I guess it could be more also. The important part is that the sum of those angles, the sum, is 90 degrees. Okay? So when you add those angles up, you get 90 degrees out of it. And the same goes for supplementary, except that the sum is 180. And so I like to remember these because I know that these are kind of similar words, just compel and supplementaries. I mean, really just the first three letters are different and the rest of the word is the same. So I like to remember these because C comes before S in the alphabet and 90 comes before 180 if you're counting up. So C comes before S and 90 comes before 180 if you're counting up. Makes sense? Just a little way to remember that in your head. So the next new vocabulary we're going to learn is a linear pair, and that means that together these angles, and of course a pair is what? Is two, right? Two things are a pair. And so together they form a line. And line, because it's linear, right? So that's where the word line comes from, is linear right there. So for example, right here, angle B and angle A are a linear pair because B is this much and A is this much. But together they form a line, and they form this line that is running right here. So the fact that they together form that green line, that makes them a linear pair. And of course, you could say at that point, you could say that angle B plus angle A equals 180. And really I should have little angle symbols out here. Angle B plus angle A equals 180 because if it equals a line, then it's going to be 180, right? Because that is what goes all the way across, is the 180. Okay? And so these are always going to be the same. Any linear pair is going to have a sum of 180 because they are forming a line. Okay? So over here, in this example, we have B plus A, and they still form a line. They form this line right here. Now don't get confused about this whole triangle business and it's like, oh, well, this is a triangle, so something else is happening. Well, yeah, this is a triangle, of course, but the linear pair simply means that there are two angles that together form a line, and so these do indeed form a line. Okay, the triangle has nothing to do with it. We will also learn later in the year that this is something called an exterior angle of a triangle, and there's a whole theorem and everything we learn for that as well. So just getting familiarized with some of these words for the first time. Okay, vertical angles, and this is one that you're going to hear me use a lot, so please pay attention to this. Vertical angles are across an intersection from each other. So if you think about it, if we have like a road intersection here, and I have, you know, a road intersection, and I have Main Street coming this way, and I don't know, Elm Street going this way, and you know, you have the crosswalk here, and the crosswalk here, and the crosswalk here, and the crosswalk here. When I say across an intersection, I mean that if I had one person here and one person here, they're diagonally across the intersection from each other. That's what we're talking about here. So when we're looking at angles, A and B are vertical from each other because they are across. So if you look at angle A is this right here, right? And angle B is this right here. They are across from each other because they are across this intersection. And so if you watch, I'm just drawing these in, and it comes pretty clear that A and B have to be the same angle, right? They're across from each other. They are across from each other like that. Across the intersection. Across that intersection right there. The same thing can happen when you have more than one. So, for example, B and A are across from each other. They are vertical angles. which means they are the same measure. They have the same measure. And also this is the same as this. Those are vertical, and they have the same measure. And this one is the same as this one, and they have the same measure. So, and usually we can just put these little tick marks to make it even clearer what we're doing here. So these blue ones are the same, these red ones are the same, and the green ones are the same, and they are all vertical angles to each other. Okay? And all vertical angles have the same measure. Adjacent, just like the word adjacent means in everyday language, adjacent just means next to each other. It could be any kind of crazy scenario, but really adjacent just means next to each other. It means they are sharing a side. So if you notice, angle B and angle A right here are sharing this side, so they're adjacent. Angle B and angle A are sharing this side, so they're adjacent. Now we can go back up here and we can say, oh, well, these two, this B and angle A, are adjacent also because they're sharing that side. And they are adjacent as well. But usually when you have something that's actually forming a line, you're going to call it a linear pair. But if it doesn't form a line, like these two, you can see this really doesn't form a line at all. It's just some kind of an angle setup. Then the only thing we are left with to describe this scenario is that it's adjacent angles. And here, this is the sum of those two angles. Now, if we had added in angle C, we could say that A, B, and C are supplementary because they add up to 180. They would make this line, right? It wouldn't be a linear pair because there's three of them, and a pair is two. But if we're just looking at what A and B are, they just make this kind of a random angle, and so they are just two angles that add up to a third angle, and the only thing we can really say about those is that they are adjacent. So we're going to look at some examples. And usually in geometry, the way that I teach, I'm going to show you some basic concepts like this, but then I'm going to ask you to apply that when you're actually doing problems, because otherwise it would just be a waste of your time to do a lot of the same boring stuff over and over again. So I like to try to make the workout problems a little bit more interesting. So here, notice I'm asking you to find the measure of angle B. Okay? Well, here's angle B. Angle B is right there. And notice that angle B, going this way, right? Angle B and this 50-degree angle make a linear pair. So we can say that whatever B is plus 50 has to be 180 because it equals a linear pair. And so we can just subtract 50 here, subtract 50 and subtract 50, and we can see that B equals 30 degrees. Cool, right? Here we see that B is vertical to this 43-degree angle, and since we know that vertical angles are the same, we know that B has to equal 43 degrees because they're vertical. Here's one that's a little bit more interesting. So if we notice here, we have a three-angle setup. We have this angle, which is angle B, and then we have this 96-degree angle, right? And then we have this 209-degree angle that goes the rest of the way around. So if we want to find angle B, overall, notice that the whole thing is going all the way around the circle, right? We're going all the way around if we do all three of them together. So all three of them together, which would be B plus 96 plus 209, all three of those together have to equal 360 because we're going all the way around. Okay, and so we can I can just use a calculator because it'll just save us the time from doing the math. 360 minus 209 minus 96 leaves me with 55. So I know that B has to equal 55 degrees. Okay? And here, notice I have a right angle. So this whole thing all together is 90 degrees. And B plus 63 equals a 90. So B plus 63 equals 90. And if I subtract 63, then I have B equals 27. Okay? A couple more examples. I'm just checking my work over here. Oh, I made a mistake. I'm sorry. Let me look back at this. This answer should be 130, obviously, not 30 degrees. 130. Sorry about that. Okay, the rest of them look good. I'm checking my answer key. Okay, so let's do a couple more of these. I'm just going to skip that one because it's easy. So here we have, this is a 90, and notice we have these other parts of the lines here that are designed to confuse you. But really B plus 29 equals 90. So if you look, we have this 90 degree angle here that we're told about. And so B plus 29 equals 90. And so I can just subtract 29 and subtract 29, and I get B equals 61. Okay. This was just like the one we did on the last page, Don't get confused because there's a triangle. 49 plus B equals 180 because it's this linear pair that creates this line right there. See? Let's go on down. Oh, and these are both vertical. So 90 equals B and B equals 73 because they're directly across the intersection from each other. See that? So let's look at these now. I love these problems, but students usually hate them. Okay, so in this scenario right here, notice that we have a line, right? This is a line. I should really just be drawing this in a color so you can see it. So this is a line, which means that 93 plus this other angle right here has to equal 180. Well, we can do that. We can say 3x plus 18 plus 93 is 180. Okay, and then it's just a linear equation. We can solve. We did this all year last year in algebra. So 180 minus 93 minus 18 divided by 3 is 23. And so x equals 23. Okay? Here we have a similar setup where we have this plus this remaining 296. Everybody see that? So I have this angle here, which is this expression, x minus 24. And I have this angle, which is 29. And then the remaining way around the circle is this 296. So if we add it all up, we're going to get 360. So 360 equals the 296 plus x minus 24 plus 29. Well, if I subtract the 296 here and here, I'm going to get 4. Oh, excuse me, not 4. Good grief. 64. Excuse me. 64 equals x minus 24 minus 29. And so then if I do 64 plus 24 plus 29, I'm going to get that x equals 117. That doesn't seem right. Let me come back to this one. It should be 59. I need to see what I'm doing wrong there. 296, 360 minus 296, 64 minus 29 plus 24. Oh, I'm sorry. I just did the math wrong. So just ignore that. The setup was right. I just did the math wrong. So x is 59. I mean, this is all just algebra, right? This is exactly what we did last year. Here we have vertical angles, so we know that the 2 plus 3x, whatever that is, has to be the same as the 62 on the other side. So if we subtract 2 and subtract 2, we have 3x equals 60, divide by 3, and we have x equals 20. Okay, and here, if we know that this is 90 and this is a line, then this has to be 90. So 6x plus 2 plus 40 has to equal 90. So 6x equals, see, 90 minus 40 is 50, minus 2 is 48, and so x equals 8.